I mentioned the 5% and how it's not the perfect answer, but it's the industry standard answer. So much of what is published today is published because this comes in under 5%. It comes under 5%, it gets published because it's unusual, and then we're done. When Fisher, who's one of the top statisticians the world has ever known, 100 years ago, I think this year's actually right too, Ken, I think it's 100 years ago, 1910-ish, he proposed the p-value at that point. And what he said the p-value should be is, it should be a measure for us to take a second look. In other words, you got surprising results. Do it again and see if you get the same surprising results. Because the chance of getting the surprising results twice in a row, if they were both outliers, is 0.05 squared, which is essentially 0. It's the same argument that is told, I mean, this, I'll tell you guys this, and you learned about it in the last project in 243. You take a breathalyzer test. You know you're sober, you take a breathalyzer test, and it blows as if you're drunk. You know it's a false positive, right? What should you demand? Another test. Why? Why doesn't the cop just say, you know what, you blew positive, screw you. You're guilty. Because it's not 100% likely. There is a false positive chance. So you can say, boom, it's a false positive. And he's going to say, well, how do you know that? He's not going to say anything. You can take it to court. And you can argue mathematically that I was sober. That was a false positive. It happens 1 time in 20. Let me blow it again. Now, of course, the problem then is if it goes to court, it's been 2 weeks and it's out of your system. But if you can take a secondary drug test, maybe a breathalyzer is not a good example. Maybe a drug test for a job is a better example, like a p-test, right? And if you know you're clean, the chance of you testing false positive twice is 1 in, it goes from 1 in 20 to 1 in 400, right? 1 in 20 squared, which is basically 0. You're not going to blow 2 false positives. And that's the best thing that can happen. If you blow a false positive, or if you pee, I guess, a false positive, and then pee a true negative, then they got to go, oh, the first one must have been a positive test result in error. That's the idea of replication, and that's what Fisher was all about 100 years ago. He said, when you get small p-values, take a second look at your experiment and see what happens. See why you got a small p-value. Then you start analyzing, like with VO2, like Jolene said, why is caffeine lowering heart rate when it shouldn't? It's kind of like it's that. It's exactly that. It's not publish, necessarily. Maybe you publish to encourage others to do the same study again. That is a noble reason. I'm putting it out there. Please, somebody else do this study too and see if it holds up. Perfectly. Especially if your funding runs out. Perfect example. But it should be a second look probability. That's what it really should be. But the general number that is used is 5% because it corresponds to 95% confidence. That's what it corresponds to, is 95% confidence. Any questions you guys have right now? Getting there?